Welcome back, guys. This is week 6, day 1. We're almost over with the school year. So today we're just going to place the date wherever you start with the exercises. Today is May 2nd, 2022. We're still not going to place the topics today because we're still missing 4 formulas besides the one that we're going to see today. So we saw in our previous class on April 29th, these 2 formulas. And we said that these formulas were formulas for perfect squares. And that's how the video was uploaded into the platform as perfect square. That is not the topic, though. That is just the name of these 2 formulas. The topic involves 7 formulas. So we're going to add it later on as we get to see the last 4 formulas that we're missing. And today we're going to see 1 more formula. So as you can see, I have 3 unsolved exercises. I got x plus 9 times x minus 9, y minus 3 times y plus 3, and 3x squared y. Give me a second over here. There. 3x squared y minus 5wz times 3x squared y plus 5wcq. Okay, so what can you notice that is common in all of those 3 exercises? What is the particularity of those 3 exercises? They have something in common, all 3. What can you say is what
the signs differ?
The sign is different. Very good. The sign is different. So it is exactly the same variable with exactly the same constant, but one is an addition and the other one is a subtraction, or the other one is a subtraction and the first one is a subtraction and the other one is an addition. That's what's different in them, and that's what's common in all of the 3 exercises. Then the terms, they're exactly the same. Okay, so what are we going to be doing when we have these cases? We're going to have to use the 3rd formula. And what does the 3rd formula say? The 3rd formula says that whenever you have a term, adding a second term in a binomial that is multiplying another binomial that has exactly the same term, the first one, but subtracting with the second term, they're the same, you're going to be saying that your answer is going to be a binomial where the first term of either parentheses, because they're the same, is 2 to the square minus the second term is also 2 to the square. And that is what you're going to be doing, okay? That's the formula that you guys are going to be using. This formula is called difference of squares. Why? Because it's a subtraction, so that's why it's a difference, and both terms are 2 to the square. So it is called difference of squares. And this is the 3rd formula that you guys are going to be using. So how are we going to solve it? I'm going to copy the first exercise again. So we got there x plus 9 times x minus 9. It doesn't matter what parentheses you use. You can use the first one or you can use the second one, because at the end, they are exactly the same, okay? So it doesn't matter. So for this one, I will be using the second parenthesis, okay? The first one, the x. This is going to be a. Just as the first 2 formulas, from the sign to the left, that whatever you have, everything that you have there, that will be a. And from the sign to the right, everything that you have there is going to be b. So in this case, what I have to the left is x. And what I have to the right of the sign, in this case, the addition sign, that's b. Okay? And what part am I using right now? I'm using only this second part. Okay? Because I'm multiplying. So instead of doing the distributive property and after that simplifying, I will be using only this. Okay? So we said that x is a, so I'm going to place a, which is x, to the square, minus b, b is 9, so I'm always placing it in between the parentheses, so 9 to the square. And now I'm simplifying. How much is x affected to the square?
X to the square.
To the square, very good. Minus, how much is 9 to the square?
81. Negative 81.
No, 81. You got already the negative of the formula, so I said minus, don't worry. 81. And that's it. You don't do nothing else. That's it. That's your final answer. Easy peasy, breezy, lemon squeezy, right? Okay, so you see we did it with the addition, with the parentheses that had the addition. Will we still get the parentheses that is with the subtraction if we do it the same way? Of course, we're going to get exactly the same answer. So I'm going to do it with a subtraction. In this case, y is to the left of the minus sign, so y is a, and b without the sign, okay, because it's only what's to the right will be the 3, okay? We're still going to use the same formula. So I'm going to copy the same formula. And I'm going to do exactly the same procedure. I'm going to place the first term, which was y, to the square, minus b, and b is 3. So 3 to the square. How much is y affected by a power 2?
Y squared.
Y squared, very good. Minus, how much is 3 to the square?
9.
So minus 9. Can I simplify anything in there? No, I cannot. Okay, so what are we going to do now? Nothing. That's my final answer. And that's it. Easy peasy, breezy, lemon squeezy, right? You just only need to observe that they're exactly the same terms, but one is an addition and the other one is a subtraction. Then you will be having to use formula 3. If you have the one parenthesis to the square or the parenthesis is multiplying itself, then you know you need to use formula 1 or formula 2, dependent of the sign of the parenthesis, okay? Now let's look at the very last exercise, which I'm going to move a little bit upward. So we got 3x squared y minus 5wz cubed times 3x squared y plus 5wz cubed. What formula should I use? Formula 1, formula 2, or perhaps formula 3? Which formula should I use? 1, 2, or 3 to solve it?
3.
Formula 3, very good. So this is the formula that I'm going to use. So let's identify A and B. And let's see, Guillermo, what is A? Let's identify A in this exercise, Guillermo. What is A? What term is A? Yeah, let's give him a second, okay? I know some of you know the answer because you're typing it on the chat or you're raising your hand. Yes, that's it, Josue. So, Guillermo, what is A? Open your microphone. Okay. Okay, Josue, or Genesis. No, Josue first, and then Genesis will help me with B. What is A, Josue?
A is 3x squared y.
So we're going to say that everything to the left of the sign is A. All of it. That's A. Okay? And it doesn't matter from what parentheses we choose. Now, Genesis, what is B?
5wz to the cube.
Exactly.
Square.
WC to the cube. So very good. That is B. So you see, I can pick A and B from the same parentheses for the addition or the subtraction, or from one of each. It doesn't matter because at the end, they're exactly the same terms. So I'm going to elevate that to the square. I'm going to say A is 3x squared y and that is to the square, minus b is 5wz cubed, and that should also go to the square. Let's see, Oibang, how do I solve this? What should I do then? Ina, how do I solve this? Look at the previous exercises. How did I solve that? And how are we going to solve it right now? Juan Diego? This is something we saw already, like in the first partial, and then we had a really quick. Yeah, something like that. Benitez? So Josue is telling us that what we need to do is multiply the exponents. That is called power of a power, where this 2 will affect the exponent of the y, will affect the exponent of the x, and will affect the exponent of the 3. And this other 2 will affect the exponent of the z, the exponent of the w, and the exponent of the 5. That is called power of a power. And Josue says that we multiply the exponents. So yes, when we have power of powers, we multiply the exponents. So the 3 has an invisible 1. So 3, 1 times 2 is 2. How much is 3 to the square? Anyone can open the microphone. How much is 3 to the square?
9.
9.
9.
How much is x squared to the square? Taking in consideration what Josue told us. And remember, power for power. So x to the square, how much is that?
X to the fourth power.
X to the fourth power. Because I multiply 2 times 2, because that's a power of power, so I get a 4. And y affected by the square, that is?
Y square. Y
Square. Minus, now we affect the 5. 5 to the square?
25.
So 25. W to the square?
W square.
W square. And z cubed to the square? Z cubed to the square? Z to the?
6th power.
6 power.
The 6th power. Very good. So that is it. We don't do nothing else. Except that when we have powers of powers, we need to multiply the exponent. Same thing would happen in these two formulas if we have exponents or more than one variable in any of the two terms, because both of them finish and start with terms that are to the square. That's why they're called perfect squares. Questions so far? No? Okay, then, so basically this is our third formula, our third special formula of this specific cases that we're gonna see. Today we're seeing the last formula for squares. We saw addition of a perfect square, which is this over here, subtraction of a perfect square or difference, which is this other here, both to the square, perfect squares. And today we got to see difference of squares. So we finished with the 3 formulas of squares, and now we're going to go with the formulas for the cubes, okay? So we have 4 formulas that we're missing, and probably we're going to see it in our next class. All of them 4 at the same time, okay? Questions? No questions? Until we finish with the four formulas that we're missing, we will be placing the topic's name. And that will be it for today.